Hello mechanical engineers. In this video I am going to explain you what stress and strain in a component is. This is an introductory session of strength of materials. So, let's get into this. At the end of this session we will know materials and few properties we need to know for classification. We will also be able to make out stress, strain and different types of stresses and strains. We will see what Hooke's law is. I know when I said material you would be thinking of something like copper or brass. But this subject is related to stress and strains and we will study these on every metal. So I take the values of metals needed when calculating the stress and strains of a specific metal. For our explanation we will consider all the metals used as materials. Materials possess three important properties we need to understand before getting into strength of materials. Elasticity, plasticity and rigidity. Elasticity in materials is a phase when the material still has capability to regain its shape back after removal of load acting. For example, if you pull a rubber band holding it on two sides, it stretches losing its original shape. As soon as you release it, it regains its shape back. This property of the material is known as elasticity. For some materials the elastic property is very high. These materials are known as elastic materials. Plasticity in materials is a phase when the material no more has a capability of regaining its shape. The material lost its shape permanently. Usually this phase occurs after elasticity. Rigidity in materials is a phase where the material do not undergo any kind of deformation. The applied force is less to create a deformation in the material. Remember the following bullet points: in reality there is no rigid body. There is no complete elastic opastic body. They are phases and are assumed based on the force acting on the body. Now let's see what stress is. The resistance offered by a body against a force acting to deform is called stress. If you are trying to deform an object by applying a force, it will generate some force inside which is known as stress. Stress is generated when a force is applied. The force acting on a body is generally called as load. Tensile force is force which make the body elongate. Two forces acting on a body to elongate its length are called tensile forces. When a tensile force is acting on a body, the body internally develops stress at every point which is equal to the force. If we cut a cross-section as shown in the picture, then the force acting at cutting plane is equal to the applied force but in opposite direction. This force is against the deformation of the body. This force is assumed to be uniform across the cross-section. All the little forces on the cross-section together form force F which is acting on the body. That is stress equals to force divided by area. Force per unit area. Units are Newton per meter square or kilogram per centimeter square. Now let us see what strain is. When a force is acting on a body, it tries to elongate and compress according to the direction of the force. So, there is increase or decrease in the size of the body. The total length of the body is the original length L plus the change in length with direction of dl. The ratio of change in length to the original length is known as strain. Strain denoted by E is equal to change in length dl divided by original length L. Types of stresses and strains. Tensile stress. Two forces acting on a body to elongate are tensile forces. The action of force is shown in the picture. The force per unit area of the body is known as tensile stress. As we already discussed, the force is tensile and the body elongates. There is a change in length and that change in length divided by original length gives the tensile strain. Compressive stress. Two forces acting on a body to compress are tensile forces. The action of force is shown in the picture. The force per unit area of the body is known as compressive stress. As we already discussed, the force is tensile and the body compresses. There is a change in length and that change in length divided by original length gives the compressive strain. Shear stress. When the force is tangentially applied as shown in the figure, then the stress generated in the body is known as shear stress. Here the displacement is horizontal. So, the change in length is shown by dotted line with t. The ratio of to the original length is called shear strain. Hooke's law. Hooke's law states that within elastic limits stress is directly proportional to strain. It means if stress increases strain increases and vice versa. Stress equals to constant multiplied by strain. Constant equal to stress divided by strain. This constant is denoted by capital E in case of axial loading and is known as Young's modulus or modulus of elasticity. E equal to P by E. Thank you for watching. Please like, comment and share our video. Do not forget to subscribe.